In today's video, I have brought you a very nice problem regarding arithmetical number theory. Here is the following setup. Find all n, x, and y as a non-negative integers. Satisfy this following equation. So what we have done here, so we have chosen a small number with big exponent minus a big number with a small exponent. So this difference is given as a power of 2, okay? So we have to select only the power of 2 when you make the difference of these two primes, okay? I have built this problem by using some experimentation and motivations and came up with this nice problem, okay? We are going to solve this equation by using very quick methods. By using the congruence notions here, it will be more easier to solve this one, okay? So let's get started. If x equals 0 and n equals 0 don't work here with y is different than 0, okay? Because if x equals to 0, I get here 1, I get here minus 5 to the y, which is impossible because we get a negative numbers here. So since we have a positive number at the right side of this equation, if n equals 0, I get number 1 here, but this difference is an even, which is impossible, okay? So which means n must be super equal to 1 at the first place. For x, also x must be super equal to 1. If y equal to 0 here, I get 1 minus 1 is 0, but this one is different than 0. So if x equals 0 with y different than 0, I get negative numbers here, which is impossible also. So always n super equal to 1, and we don't care about y yet, okay? So the second thing that I'm going to do here, suppose y is super equal to 3, okay? If y is super equal to 3, I'm going to reduce this one to mod 125. If y is super equal to 3, so I get here at least I get here 125 at least, which means this term it will be divisible by 125. So which means we are going to reduce this one to mod 125. So if I'm going to do that, I will get 3 to the x is a congruent 2 to the n mod 125, because this one is already 0. So the only thing left, we are going to make the comparison between the left and the right side of this equation. So we are going to compare the reminders, okay, for this one and this one when we reduce this one to mod 125. So let's define a set which for this power of 3. So we will treat the x from this set 3 squared, 3 cubed, and area 1, which is 3 to the 4th. We are going to stop here. Then the other one, I get 2 to the n from this set. We get 2, 4, 8, 16, 32, and 64. We are going also to stop here. Why I'm doing this one? We are going to use the residue module here. So instead to get the positive reminders, I'm going to deal with the negative reminders. When you have a big module here, so if you're using the big reminders, we are going to calculate all the exponents. This exponent will be huge numbers, so it will be more difficult to find the reminders for each time, okay? Because this one is growing quickly up as well as this one, so which means you will have a crazy calculation. So we are going to stop until we see the kind of patterns here. So we are going to use a small technique here in order to determine the reminders for both terms, okay? So we are not going to pass this one. If we pass in this one, if I get 3 to the 5th, which is 243, we pass in 125, okay? Also here, if I'm going to put the next number, I get 128, which is past 125. We are going to stop here. Then I calculate the difference of reminders when you divide this one by 125. Let's start this one. Let's call this set as a capital A and this one as a capital B, okay? So let's set x from capital A and y from capital B, okay? Now let's calculate the reminders of this one. So I get the first possibility, x is a congruent, I'm going to use this one, 3 minus 125, which is minus 122. minus 122 mod 125. So the next potential value, the next potential reminders for the next one. So I get 3 square, which is 9 minus 125. I get minus 116 mod 125. The next value, so which is this one, which is 27. I get 125 minus 27, which is minus 98. Minus 98 mod 125. Lastly, I get this 125 minus area 1. I get here minus 44 mod 125. Okay, so I have done with this one. Let's move on to the next one. So for this one, I get y is a congruent to 2 minus 125, which is minus 123 mod 125. In the value, I get 125 minus 4, which is a congruent to minus 121 mod 125. For the third value, I get 8 minus this one, which is 125 minus 8, which is minus 117 mod 125. The fourth one, I get minus 109 minus 109 mod 125. For the fifth value, which is 32, so I get 125 minus 32, 125. For the last one, I get 125 minus, I get 64 minus 125, which is minus 61. So I get congruent, y is a congruent to minus 61 mod 125. Okay, so I finish with those reminders. This is all the potential reminders. So if you take a look carefully for each value of these reminders, none of these are equal to each other. Okay, which means we have no solutions. No solutions when we have y is super or equal to 3, which means y must be strictly inferior than 3. In the other word, y is belongs to this set 0, 1 and 2. Okay, because we are dealing with non-negative integers including 0. Okay, so now let's erase this board and go through each case when we have y equals 0, 1 and 2. Okay, if y equals 0, so now the equation becomes more simple. So by taking this value of y and insert it back into the original equation to see what's given us, we get 3 to the x minus number 1 equals 2 to the n. So the next thing that I'm going to do now, I'm going to use a small technique in order to find the solution for this one. If I'm going to assume if n is super or equal to 2, which means this term will be divisible by number 4, because I get 2 square, 4, 2 to the 3, 2 to the 4, and so on and so forth. Okay, so this one is always is a congruent to 0 mod 4. So let's do that. I get here minus 1 to the x is a congruent to 1 mod 4. So how I get from this one to this one? So I split this term into 2 terms. I get 4 minus 1 to the x. 4 equals to 0 because it's divisible by number 4. I will be left with minus 1 by moving this minus 1 to the right, and then this one will be 0 mod 4 because we have n is super equal to 2 here. So in order to get this statement true, we must have x even here. So which means x is an even. If x is an even, let's set x equals to m. Taking this value of x and insert it into this equation, I get 3 to the 2m minus number 1, which equals 3 to the m minus number 1 factor 3 to the m plus number 1. So what I have done here, I have a difference of 2 squares and factor out that on this form. This product equals to this one, 2 to the n. This one become a power of 2 because the right hand side of this equation is a power of 2. So let's solve this equation quickly here. I get 3 to the m minus number 1 equals 2 to the a, and 3 to the m plus number 1 equals 2 to the b, where is b strictly superior than a. Okay, so since I have a power of 2 here, which means this term of this product is a power of 2, this one is a power of 2. We split this product into 2 by sharing number 2 as a power for both terms. So in order to solve this equation, let's make this equation minus this equation. I get a rate of 3 to the m. I will be left with 1 minus 1, which is 2. So get here 2 equals 2 to the b minus 2 to the a. Taking 2 to the a as a common factor because this one is smaller than this one, I get 2 to the b minus a minus number 1. Okay, we know this term is odd, but this one is even. So this one is telling us a minus equals 1. So we don't have to solve this equation. I'm simply going to take this value of a and insert it back into this equation. If I'm going to do that, I will get number 2 here, 2 to the 1, which is 2. So by moving over minus 1 to the right, I get 3 to the m equals 3 plus number 1, which equals 3. The exponent equals 1. So here m equals 1. Taking this value of m, which is 1, and then replace it here to find x, so which means I get x equals 2 here. If x equals 2, which means I will find n here. So get 3 squared minus 1, which equals 9 minus 1, which is 8. 8 is the same as 2 cubed. 2 cubed equals to the n, which means n equals 3 here. Okay, I'm going to write the solution up here. So I get a first solution x equals 2, as I found there, with y equals 0, which is this one, with n equals 3. Okay, replacing this value into the original one, you get the equation satisfied. Okay, got 9 here, you got minus 1, which is 8 cubed, which is this one, which is 2 to the 3. So what about if n equals 1? Because we have chosen this statement to be n superior to 2, but we miss in one case if n equals 1 here. We know n is not equal to 0, which means n is superior to 1. If I'm going to take the value n equals 1 and replace it directly to this equation, I will find x easily here. Okay, if I get x, I get y, same value y, I get n because we have chosen n equals 1. N equals 1, I get 2 here. By moving over minus 1 to the right, I get 3 here, which means x equals 1. So I found 2 solutions here. Let's move on to the next case when we have y equals 1. Okay, so I'm going to use a very nice trick here. So let's replace this value of y into this equation. I get 3 to the x minus 5 equals 2 to the n. Okay, so the trick that I'm going to use here, what about if n is superior to 3? So if n is superior to 3, so this one will be divisible by number 8. So let's reduce this one to mod 8. So I get here 3 to the x minus 5 is a congruent to 0 mod 8. Okay, because I get here 2 to the 3 as a minimum value here, 2 to the 4th, 2 to the 5th, all of those are divisible number 8. Okay, so let's take this minus 5 to the right. I get 3 to the x is a congruent to 5 mod 8. Okay, so I have ended with this nice expression. So the next thing up, this one, and let's go to the chart and state all the values of x in order to check what's the remainder of 3 to the x. If they have a same remainder, which means we have a solution for this equation. If it has a different remainder, which is not 5, which doesn't accept any solutions. Okay, this is the chart. This is the following values. Let's take this one in general. Let's k and 3 to the k. We have a following values 0, 1, 2, 3, 4, 5, 6, and so on and so forth. Okay, so for this one, to get 0 here, 3 to the 0, which is number 1, I get 3 here, 3 square, which is 9. This will be reached to the mod 8. So I get 2 square, which is 9. 9 is 1 more 8, which is the remainder is number 1. I get 3 to the 3, which is 27. 27 is 3 more than 24, which is the remainder is 3. For the number 4, I get 3 to the 4, which is 81. 81 is 1 more 80, okay, which is the remainder number 1. For 5, I get 3 to the 5, which is 243. 243 is 3 more than 240, because 240 is divisible number 8. The remainder equals 3 here. 3 to the 6. To the 6 is the same as 3 to the 4th is multiplied by 3 square. We know 3 to the 4th is a remainder number 1. 3 square is a remainder number 1 because it's 9. This one is a remainder number 1 here. So if you take a look carefully at this pattern, if you take a look carefully at these remainders, so this one is kind of repeating. We have 1, 3, 1, 3, 1, and so on and so forth, which means this 3 to the k belongs to this set 1 and 3. But the problem, we have absence of number 5 here. This means this equation is not accepting any solution when we have n is superior to 3. This is impossible, which means since n superior to 3 doesn't work, which means n must be strictly superior than 3. In the other word, n is taking this set 1 and 2 only. Okay, so let's start in with number 1 here. If n equals 1, I get 3 to the x minus 5 equals 2. Let's move over minus 5 to the right. I get 3 to the x equals 7. This is impossible, because we get left hand side of this equation is a power of 3, but the right hand side of this equation is not a power of 3, which means n not equal to 1, which means n must be equals 2. If n equals 2, let's replace it into this one here to get 3 to the x minus 5 equals 2 square, which is 4. Let's move over this term to the right. I get 3 to the x equals 4 plus 5, which is 9, is the same as 3 square. In the other word, x equals 2. So we get the third solution. We get x equals 2 with y equals 1 with n equals 2. Okay, so we found the third solution. Now let's move on to the last case when we have y equals 2. So in the last case, which is case number 3, so I'm simply going to do the same thing, replacing this value of y into the original one. I get 3 to the x minus 5 square, which is 25, equals 2 to the n. Okay, so the trick that I'm going to use here also, if n is superior equal to 2. Okay, so let's do this one by the way of contradiction. Suppose n is superior equal to 2. Okay, so if n is superior equal to 2, I'm going to do the same job that I have done before. So by reducing this one to mod 4, I get here minus 1 to the x. This minus 125 becomes 25, which is 24 plus number 1. 24 will be divisible number 4. I will be left with minus number 1 here is a congruent to 0 mod 4. Okay, let's take this minus 1 to the right. I get minus to the x is a congruent to 1 mod 4. So this one is telling us x is an even. Why x is an even? If we replace x with an even number here, if we replace x with an even integer, this minus 1 turns into 1, which is true. We get 1 is a congruent to 1 mod 4. If you replace x with the odds, we will get minus 1, which is not true. Okay, which means x is an even. If x is an even, let's set x equals to c. Okay, let's take this value of x and insert it here. So I get 3 to c minus 25, which is the same as 5 squared, equals 2 to the n. Let's put this one on the form of the product because I have a difference of 2 squares. I get 3 to the c minus 5 factor 3 to the c plus number 5 equals 2 to the n. So I get a power of 2 here. So it's more simple here to put 3 to the c minus 5 equals 2 to the I, and 3 to the c plus number 5 equals 2 to the g, where is g strictly superior than I. Let's make the difference of these two equations. I get rid of 3 to the c, I will be left with 5 minus 5, which is 10. Okay, I get 10 is equals 2 to the j minus 2 to the I, which equals 2 to the I factor 2 to the j minus I minus number 1. So the next thing up, I'm going to divide both sides by number 2. Okay, keep in mind, if I'm going to divide this one by number 2, make sure I is super equal to 1. When I is super equal to 1. If I equal to 0, it will be impossible to divide by number 2. You get this one not integer, which is impossible to divide by number 2. Okay, so always have to keep I is super equal to 1 in order to divide both sides by number 2. So I will be left with 5 here equals 2 to the I minus number 1 factor 2 to the j minus I minus number 1. Okay, so I get this term is a odd, but this one is a even. So it's impossible to leave number 2 here as a even. We need this exponent must be equals 0. Okay, which means I minus number 1 equals 0. In the other word, I equals 1. Okay, if I equals 1, let's take this value of I and insert it into this equation. I get 3 to the c minus 5 equals 2. Let's move over minus 5 to the right. I get 3 to the c equals 7. This is also, it's impossible, because you get 3 to the c as a power of 3, but 7 is not power of 3, which means impossible. What does mean impossible? Which means this solution above number 2 and above number 2, which is impossible, which means n must equals 1. Okay, if n equals 1, let's replace the value of n into this one. I get here 3 to the x minus 25 equals 2, because n was replaced with number 1. So let's move over minus 25 to the right. I get 3 to the x equals 27 is the same as 3 cubed. So we get the exponent 3 here. We get x equals 3 here. So let's set the last solution. I get x equals 3 with y equals 2 with n equals 1. Okay, so I have ended with this video. If you have any question regarding this problem, just put it in the comment section below. So don't forget to hit the subscribe button and support the channel, and thank you for watching. I will see you next video. Bye.